Hello, welcome to today's lesson on 5.8, which will be the last lesson for Chapter 5, and actually will be the last video before Thanksgiving. So, 5.8 is about analyzing graphs of polynomial functions. We haven't really done too much graphing, so I think it's a good idea that we talk about it now. So, we're going to do 3 examples today. Here's example 1. So example number 1 is the graph of the following. Graph y equals 1/3 x plus 3 x minus 2 squared. So here's the thing we want to do. Find end behavior, which I'll label as EB. Find x-intercepts, if possible. And number 3, find the y-intercept. That's always possible. So the end behavior, we kind of did this a while ago, but you might have forgotten. What you want to do is focus on degree. And leading coefficient. Now if I were to FOIL this, you would get something like this. 1/3 x cubed plus dot dot dot. How do I know that? I know that because this right here will be x squared minus 4x plus 4. And when I multiply the x plus 3, these two terms become x cubed. That'll be the highest degree. But I got the 1/3, so when I distribute the 1/3, I get 1/3 x cubed. Now, if that's positive and that's odd, we talked about this a long time ago, but may have forgotten. Degree, LC, EB. Leading coefficient I abbreviate as LC. If the degree is even and leading coefficient is positive, both arrows point up. If the degree is odd and leading coefficient is negative, if the degree is even and negative, they both point down. But odd, they're going in opposite directions. So positive will be like this. Odd negative will be like that. So in this case, my end behavior is going to be more like the third case right here. We'll come back to that a little later. For step 2, for the x-intercepts, just by looking at it, I know it's going to be -3 and +2. And here's the reason why. X plus 3 equals 0. X equals -3. X minus 2 equals 0. X equals 2. This also is going to play a role in a little while. You'll see how. Y-intercepts, just plug in 0 for y. Sorry, plug in 0 for x. 1/3, 0 plus 3 squared, 0 minus 2. Wow, I'm really messing up today. 0 plus 3 times 0 minus 2 squared. So it's 1/3 times 3 times 4, because -2 squared is 4, so you get 4. Okay. So now all I have to do is graph it. Make some tick marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. We'll do a fifth one. Okay. So using blue now, the graph. So we know x-intercepts at -3, and is 1 at 2. And we know the end behavior has to be like this, based upon what we saw there. And y-intercepts at 4. So graph will look something kind of like that. And that's your graph. Notice how there's a bounce. I think I mentioned this on the video over the weekend. If a 0 shows up an even number of times, so a bounce if a 0 shows up an even number of times. Looking back up here, say I said we're going to come back to this. The x minus 2 squared means x minus 2 times x minus 2. So it means you have 2 as a 0 twice. So the 0 shows up 2 times. So you might be getting a bounce. But here, the exponent's 1, so it passes through. Plus the end behavior has to be going down and up. And you can't have it crossing again, because if you did this, you have an unnecessary 0. Because we only know the zeros are -3 and 2, so we can't have it crossing a third time based upon the way the function was written. So that wouldn't work for us. So that's how the graph looks. Let's try actually one more example. Because I've noticed the videos have been kind of long lately, so I don't think I have to do 3 examples today. So let's say you are making a rectangular box from a 16-inch by 20-inch piece of cardboard. If you cut out 4 square corners, of the same dimension, what is the maximum volume of this box? So that's the question we're trying to find. So if you think about it, volume is length times width times height. So V equals length times width times height. And a rectangular piece of cardboard may look like this, where it's 16 this way and 20 that way. And we're going to cut out corners like this. Where it's going to be X on each side, because we don't know how long each side of the corner is going to be. So when you fold up the flaps after corners have been cut out, your box will look something like this. Not the best looking box, but it'll look something like this, where the height will be x, that will be 16 minus 2x, and that will be 20 minus 2x. The reason why is because you had 20 here, but you lost x and x. And you had 16 here, but you lost x and x. And when you fold it up, the height will be x. So your volume is now this, x times 60 minus 2x times 20 minus 2x. What I would do to find max volume, graph in your calculator. So I would say y1 equals x, parentheses 60 minus 2x, parentheses 20 minus 2x. And for my window, x min, you're obviously not going to have a negative dimension or negative x value, so we'll do 0. X max we'll say is 8, and x scale we'll keep it at 1. Y min, let's go with 0 because you're not going to have a negative volume. Y max I'm not sure. This you want to experiment with. So for now, and the y scale I'm not sure either. So for now, let's say that will be 100, and that'll be 10. See if we can find a max. So I go ahead and graph it. So it's x, 16 minus 2x, 20 minus 2x. Change the window. Okay, I don't see much. So let's bump it up to, say, 400. Make that 40 for the y scale. So it's a little bit better. You might want to have your calculator while you're doing this. Let's go to 550. So this is a skill that you need to have. Okay, graph. Okay, that's a lot better. So graph will look something kind of like this. And this is what you want. You guys should know how to find this. To find max, you want to go second, trace, option 4. And it should be pretty easy. Left bound means go to the left of where you feel it is. Right bound means go to the right where you feel it is, the maximum that is. And just hit enter again for the guess. So I'm getting 2.94 and y equals 420.11. So, and remember, we let y be v, so max volume is 420.11 cubic, because it's volume, inches. And the cuts, we cut out 2.94 inch by 2.94 inch squares. And the dimensions of the box was 2.94 by 16 minus 2.94 by 20 minus 2 times. Okay, I'm actually doing this a little bit too fast here. Let me erase this. 2.94 by 16 minus 2 times 2.94 by 20 minus 2 times 2.94. Or one could say it would be roughly 2.94 inches by 10.12 inches by 14.12 inches. So it looks like a D period's about to begin, so I have to end this video. So we'll do some classwork on this during block number 1. Goodbye.